Hi everyone, this is Mrs. Jackson and this is Chapter 2, Section 1, Part 1, very first video of a new chapter. And this entire chapter is on quadratic functions. This first section, thankfully, is somewhat of a review, however, where we're going to be talking about the vertex form of a quadratic function. And we already had a lot of experience with that in the Chapter 1. So first things first, the standard form, which we're going to spend more time on later in this chapter, is f of x equals ax squared plus bx plus c. And you may have seen the standard form back in Algebra 1 when you were factoring quadratics. The only qualifier here is that we have to say a cannot equal to 1. Cannot equal to 0, because we do need that x squared term. We don't need b, we don't need c, but in order to be a quadratic, we need that x squared term. The parent of a quadratic function, we already looked at quite a bit in Chapter 1, is f of x equals x squared. That's our most basic quadratic, and the shape of that function is either an upwards or downward facing U. I'll try to put both of those in there. And we already know that it's called a parabola. So far, we've spent the most time looking at the vertex form because we can see the transformations right in the equation. And as we already know, A, or I should say maybe the absolute value of A, is our stretch factor. It's either going to be a stretch or a compression vertically. And the sign of A, of course, is important as well. So if A is less than 0, in other words, if it's negative, then that is a reflection. It's a downward facing U, and we would call that a reflection over the x-axis. And if A is greater than 1, we've got vertical stretch. And if A is less than 1, I'll just say and greater than 0, we have compression, so vertical compression. Let me try to here. Okay, great. Now the H, of course, is our horizontal translation. And we already know that if we're saying x plus h, that means we're going left. And if we say x minus h, that means we're going right. And so that h actually is, maybe I'll just put this in here. So x minus h, we're going to the right. And x plus h, we're going left. And that h is the x coordinate of our vertex. And finally, k is our vertical translation. And if we add a number, then we're going up. So plus k is up, minus k is down, and of course k is our y coordinate of our function, of our vertex. So I'll just put here the vertex is h comma k. Okay, and the vertex also kind of tells you what's a min or max. So if we have our vertex information in some kind of real world application, it's either the minimum point for an upward facing U, or it would be a maximum for a downward facing U. And as I already said, the vertex is at h comma k. All quadratic functions can be described as a set or series of transformations of the parent function. And we know that that's y equals x squared, or f of x equals x squared. All right, so this is our first section here, and it's all review from chapter 1. I hope this helps. Thanks for listening.